So chemists, now we're starting to talk about acid-base neutralization reactions. So the general formula for acid-base neutralization reactions are we take an acid, add it to metal hydroxide, and produce water and an ionic compound. Again, take an acid, add it to metal hydroxide, produce water and an ionic salt. Okay? The acid is a proton donor. All acids are proton donors. Proton is H+. So to be an acid, it must have an H+ that it will give up. So all acids contain an H+ that it gives up. And the examples we're talking about here are Bronsted acids and bases. You'll see that on your homework sheet, the word Bronsted. Okay, metal hydroxides for neutralization reactions are our base. Okay, and they're going to be proton acceptors, meaning they're accepting the H+. One of the products is always water for neutralization reactions, and the other is an ionic salt. An ionic salt is just an ionic compound made up of a cation and an anion, but the cation is not H+, and the anion is not OH- or O2-. Okay, so let's just do some examples here. For the first example, we have HCl, and it's aqueous, and we add it to sodium hydroxide, NaOH, and that's aqueous. Okay, similarly to precipitation reactions, we're going to circle the cations, and we're going to switch them. Okay, just like a precipitation reaction, this is a double displacement, because we're circling two and we're switching them. We're doing a double displacement, taking two ions and switching them. Okay, you'll notice that when we take the H and switch it, it's going to join the OH. Well, what is HOH? Also known as H2O. That's why that's always one of our products, because we have the OH of the metal hydroxide. Remember, hydroxide means OH-. We have the OH- coming in and taking that H+. Because it's a base, it takes an H+, and that's always going to form H2O. The other product, what we have left, is Na and Cl. Na is +1, and Cl is -1, so that comes together as NaCl. That is aqueous. Water is a liquid, so we write an L. You don't write aqueous for water, because remember, aqueous means dissolved in water, so water dissolved in water doesn't make sense. Okay, but those are our two products, H2O liquid plus NaCl aqueous. Okay, one way to see the difference between this and a precipitation reaction, like the ones we did, was that this contains an acid and a base. The base will be a metal hydroxide, meaning it will contain this OH-, and the acid will contain an H+. Okay? And then the last step, I would like you to label them. So HCl, it contains the H+, that's going to be the acid, and NaOH is going to be the base because it contains the OH-, the hydroxide. Okay, so on the next slide, we'll do some examples on your own. So now please try to do these examples on your own. For example number 1, we have H2SO4 being added to KOH. Please figure out what the products are and then label acid and base for your two reactants. Label them acid and base, figure out the products, and please balance the equation when you're done. Number 2, we have CH3COOH being added to NaOH. Again, label these reactants acid and base, and then write the products and balance it. And number 3, I got a little tricky on you, cobalt-3 hydroxide and acetic acid. So you got to figure out what those symbols are for the reactants. Okay, label them acid and base, and then write an arrow and write the products and balance it. So I'll write the answers, but please do this now. Pause the video and do it on your own. Okay, so here are the answers for H2SO4 for number 1. We're going to take H2SO4, which is sulfuric acid. That's our acid. We know it because it contains H. Okay, it contains H+. We add it to KOH, potassium hydroxide. We know it's our base because it contains the OH-. Okay, we're going to switch the H's and the K's. So the H will come over with the OH and make water. Okay, and then the K is going to join with the SO4. Okay, I'll draw a black arrow for that. The K is going to join with the SO4, but let's think about how it does that. The K has a charge of +1, SO4 has a charge of -2, so we must need two Ks. So it's K2SO4. To balance it out, because there's two Ks there, we need a 2 in front of here, and then we'll throw a 2 in front of water to balance it out. Okay, for number 2, we have CH3COOH, but remember that the ion here is CH3COO- coming together with H+. This is the one tricky example where the H+ is at the end. It's written, the cation is written at the end, not the beginning. So we got to remember that's the cation that's going to switch with Na. So that H is going to join the OH minus to become H2O, and the Na is going to join the CH3COO. Because it's CH3COO minus and it's Na plus, we just write it NaCH3COO. I prefer you to do it this way. I have seen it CH3COO Na, but let's be consistent and write it this way, and that is aqueous. Okay? The acid is the first one, acetic acid, and the base is the second one. Again, we know because of the OH minus, the hydroxide. Now for the last one, cobalt-3 hydroxide. Cobalt-3 means it's cobalt-3 plus, and hydroxide is OH minus. So we must need 3 hydroxides to cancel it out. So we write that COOH3. Okay, that contains the OH minus, so that's our base. And add it to acetic acid, which is CH3COOH, that's our acid. And then we'll get, of course, water is one of our products that comes from the H on the end of acetic acid. That H joins with the OH minus to become H2O. And then the cobalt, the CO, is going to join with the CH3COO minus. But because it's CO3 plus and it's CH3COO minus 1, we must need 3 of them. I'll write that here, CH3COO minus 1. So when these join together, we must need 3 of the acetates of the CH3COO minuses. So that's why we write it CH3COO subscript 3. Okay, then to balance it, because we have 3 acetates here, we're going to put a 3 in front here, and then throw a 3 in front of water, and now it's all balanced. Okay, nice work, and you can work on the homework sheet.